Hello everyone. In this video, we'll go over the product rule for probabilities. The product rule allows us to find the probability that in two consecutive trials, so if we conduct two trials, one after the other, the probability that the event A occurs in the first trial and the event B occurs in the second trial is given by this formula. It's probability that event A occurs in the first trial times the probability that the event B occurs in the second trial, given that the event A has occurred in the first trial. This is very important to understand here. P of B backslash A is what's called a conditional probability of B given that A has occurred. So we make sure to take into account the fact that the event A has occurred by the time we look at getting the probability that the event B occurs. Why is that important though? It's because that conditional probability that B occurs, given that A has occurred, may or may not be the same as the probability that B occurs no matter whether or not A has occurred. So P of B. So we have two options here. So when the conditional probability, so probability that B occurs given that A has occurred, is the same as the probability that B occurs, we say that the two events A and B are independent. So the idea is that knowing that we have that extra piece of information, knowing that A has occurred, does not affect the occurrence of B. The two events in that case are said to be independent. The reverse scenario is when the two probabilities are different. In that case, the two events are said to be dependent. And again, what that means is knowing that extra piece of information did affect the probability that B occurs, the probability of the occurrence of the event B. So let's go over an example to really make sure we're okay with this idea. So here we're given 50 test results from subjects who took drug tests. They all use drugs. So 45 of the 50 subjects tested positive, whereas 5 tested negative. First question, if 2 of the 50 subjects are randomly selected with replacement, meaning after we pick the first person, that person is put back into the pool. So each time we pick out of 50 individuals, all the 50 subjects. So if 2 of these 50 subjects are randomly selected with replacement, find the probability the first selected person had a positive test result and the second selected person had a negative test result. So we ask for P of first test positive and the second tests negative. According to the product rule, we need the probability that the first tests positive and multiply that by the probability that the second tests negative, given that the first tested positive. So let's find the first probability, the probability that the first person tested positive. So 45 tested positive out of 50. So that's the first probability that the person, a randomly chosen person, the first one tested positive. Now, let's move on to the probability that the second person tested negative, given that the first tested positive. So again, because here it's the selections are made with replacement, that means by the time we pick the second person, we're still picking out of the 50 individuals, because the first chosen person was replaced into the group, the selection pool. So out of those 50, how many tested negative? 5. So this will be the probability we're looking for. Now, one thing to note here is the fact that because the selection was made with replacements, these two events were independent. So the probability that the second person tested negative, given that the first person tested positive, was the same as if we had disregarded the fact that the first person has tested positive. It would have still been 5 over 50. Again, because these two events in this case are independent. Now, moving on to the next question. This time, we are asked to find the same probability, but this time assuming the subjects are selected without replacement. So this time around, things do change, because knowing that the first person was picked among the 45 folks that were that tested positive, by the time we pick the second person, the selection pool is not 50 anymore. It's gone down to 49 folks. So we still apply the product rule. So we get probability that the first one tested positive times the probability that the second tested negative, given that the first tested positive and was not put back into the selection pool. So the first probability is still 45 out of 50 over 50. And then the second one, we're selecting among the 5 folks that tested negative, which there were 5 of them. And because the first selected person was not replaced into the selection pool, the denominator goes down to 49. So this is how we go about solving or thinking about the product rule and independent versus dependent events. Thank you.